I'm super excited to be here today. I think it's a topic that's obviously very core to our business, but at the same time, it's very thought-provoking because everybody cares about something, obviously, right? So financial, everything. There's something important that you care about, and obviously security plays a big part to that, right? Security is about protecting things that you care about, and financial payment system obviously is a big part of that. I like this quote. I'm sure some of you have seen this before. Security is truly about a holistic approach. It's about end-to-end. It's processes. It's people. And as we start to move towards a very different stage of innovation, if you looked at the agility, the time to innovate, time to market is changing, you will see that it's becoming more and more obvious that the old way of tying down things to protect things is not going to work anymore. We're looking at a much more different landscape. And so today I'm going to talk a bit about mobile banking, payment systems, and security. I think I'm talking to the right crowd today. You guys understand this better than I do. On mobile banking, some of these numbers are slightly old, actually, if you will. But there is no question about mobile banking is critical. Payment systems, mobile banking, transactions online, especially with mobile, is just changing the world. Whether it's e-commerce systems, whether it's just convenience of it, is also changing brick and mortar. If you look at some of this, I won't go through all of that, but if you look at it's considered #1 channel for a lot of the retail banks to engage the customers. And we're not talking about just viewing account numbers and viewing information anymore. We're talking about actually doing transactions. Or if you looked at the number of cash transactions being used versus mobile transactions, right? You see that there was a huge shift where people are starting to see the convenience of it. I don't know if you guys use it, but I use it constantly. I use it every day. I, in fact, would walk up to a cashier and ask him, would you take mobile payment? Would you actually take NFC? There's a cool factor to it, but there's also a lot to do with actual visibility to the user himself. Because that person would now understand where that money, that transaction is actually going versus waiting for a month or 2 months and so on. That instant gratification is really real. And I hate to say, but when there's money, you're always going to see threats, right? When there's interest, when there's something that's important to you, you're going to see that people would find interest in it and they want to get their hands on it. So, and I'm glad that Gartner and Forrester both agree that they're starting to see a trend that's growing more and more, especially around mobile devices, whether it's bring your own device situation, or it's just people using mobile devices on their own for consumer products. You see more and more there is an interest from the hacking community to actually attack these different applications. So some of these numbers you see up here, these are the top applications, mobile application I'm sure that you actually have in your phone today. Over 97%, this is from internal data, over 97% of Android applications have been either attacked successfully or there are attempts of it. And then for iOS, they're 87% as well. And I'm drawing that Android circle a little bit bigger because obviously that coverage here is a little bit bigger. But you see that the attack and the interest to actually attack these applications is very, very high. And it was even more so a reason to obviously protect them. Now, these applications on your mobile phone, these applications, IoT devices, these are applications on hubs that you can actually reach even today if you look around you. So how do you protect these applications? It's not about just protecting your firewalls anymore. It's not just about tying up your network security anymore. So how would you protect these applications? I'm going back in time a little bit here. As I was saying, if you look at security, we're very much used to be in this space on the left side here, where a lot of it has to do with testing, making sure that the applications are tight and secure, which is all valid, still valid, will always be valid, and tightening down your network security, right? That's when everything is still in a data center. That's when everything is still within a controlled environment within your back data center, and then what you really want to do is protect that. That's not true anymore. If you looked at most of the major attacks within the last 10, 15 years, they all started out where? At the edge, which is closest to the user. Whether it's a mobile phone, it's a device that's close to you, it's an IoT device, it's your car. it starts with static and dynamic analysis on the device first, to understand what happens with the protocol, to understand what happens with the backend, to understand how do we get our hands on it. So that world has changed. We're here today. We're not waiting for tomorrow. This is here today. So your mobile application has keys built into the application that's important to actually connect to the backend server. Where's that key? It's in the app. Is it easy to get to? Extremely. So I think we're talking about, and it's not one versus the other one. It's an extension. It's understanding that, yes, we need the left-hand side, and we also need the right-hand side to be able to protect your system, your data, your transactions, your applications, your logic, your business, your brand. And this is what application self-protection is all about, which is making sure that the application itself, make the assumption that the application would be accessible by anybody. It's what we call white box. Anybody can get their hands on it. Of course, you get in the App Store, you can actually download the application. You get a little, I was actually doing another presentation about IoT. You get a milk crate, you can stand up on top of a milk crate, you can get your hands on top to the CCTV, you can get the CCTV, you can reflash it. You get to an access point. Imagine if somebody reflashed the access point that you guys are using today. That's happening. So the application itself needs to be protected, both on a device, and obviously you still need to protect your perimeter in the back end. HCE, right, host card emulation. Obviously, you're seeing there is a shift from a lot of the hardware-based only solution over to software-based solution for very good reasons, obviously. There's solutions that are tailored specifically for that, like HCE, for example, and obviously there's tokenization built into it and so on. And the beauty of it is that it will go in pace with your innovation rate, because obviously hardware would tie it down. But software will allow you to actually innovate as fast as you could go together with your needs of the customers. XCE is a very good solution for that, right? But at the same time, if you need to support offline mode, if you need to support transactions, somehow at some point in time, you need to run a transaction. You need to pull the key out. It goes into memory, then what happens? I can scrape it. So it's not just about making sure that the encryption algorithms are perfect, they're standard, and so on. You have to look at the whole approach, both static, which is at rest, and then dynamic, which is runtime, and then the transaction, which is your network. And if you miss one part, guess where they're going to attack? They're not going to attack the one that you tied down. They're not going to go through your front door because they know you locked your front door. Where are you going to go? The door that's not locked. And then you have a whole swarm going towards that direction. So XC is a wonderful solution. At the same time, you really have to protect them across all the platform, all the devices, because just in case you share some keys, whether it's one single D, triple S key, whatever key that you actually end up using one of those solutions, you steal it from one, it's still stolen. So you need to make sure that you cover all your landscape. I kind of jumped into this a little bit. I talked about this a little bit, but this is just a very high level of how people actually attack these applications and what do they do with them. So if you looked at just the left-hand side, a very typical case, you can get your hands on the application. Anybody could, right? Go to an app store, pay 5 cents or $50 or whatever it is, but you can get your hands on the application. And you can understand what the application does by simply just decipher it. I actually have a small video I'm going to show, a very short one. That's going to give you an example of how actually people could do it with just off the shelf, just even open source some of the times, tools with a couple of commands, and you can actually pull out the memory. You can understand where the entry points are, you can understand where the keys are, and you can pull those keys out. So the first step usually is just to decipher the application. So meaning that you pull the application out, you decrypt some of the parts, and then you actually start to scrape it. This is just static. You don't even need to run it. Nobody even knows about it. You don't even need to run it. This is all static. Static in the sense that it's at rest. You're just dealing with the file. And then you open up and examine it. This is the dynamic part, which is you run it, and you start running it either inside an emulator, a container, to actually understand what it does. Now you're really exposed, right? Think about heartbeat. Think about WCS. Think about all these different cases. Where are they exposed? When they're running, right? When you're running, you have to pull the key out. You have to pull the data out somehow to manage it. And when you actually start to do that, that's when they actually start to scrape the memory, pull it out, extract it, and use it for whatever. Even if they can't do that, if they can understand how your code works, they figure out what the entry points are, they could still code lift it in a sense that this whole piece, why don't I just lift it and run it, wrap it around my code? System won't know. It'll look the same. That's why you need to make the whole application one atomic unit, in a sense that they have to run together. Okay? And then, now you have the hack version. And in some cases, not every time, like some people stop at 1, some people stop at 2, some stop at 3, some stop at 4. Sometimes you start having people actually have a weaponized version of it. That's when your brand really got destroyed, which is they would actually inject code into it, and now they redistribute it. Xcode Ghost, you heard about that within the news, where people actually modified version of a development tool so that they can inject code into it, modified Apple's development tool and shipped it out. That's not only a matter of being attacked, it actually poisoned all the applications generated from that tool afterwards. But on top of it, you lose that trust with your customer. Because now people will look at your logo again and they would say, well, I don't trust that logo. And that's the biggest damage. That's the damage that we're talking about, which is losing that trust between the brand and the user. Right? Oops. Let's see if there's a way to.
The goal of reverse engineering is to recreate original source code as accurately as possible. This source code represents the payment processor loaded within a mobile banking app. We are interested in taking the final binary form of the code and getting source code to as close to this as possible. To do so, we will first convert the Android app into its Java bytecode equivalent using the freely available tool Dex2Jar. This tool produces a set of Java class files stored within a jar. Next, we use JDGUI to create what it thinks is the original source code based on the contents of this jar. Using these freely available tools, the reverse-engineered code for the payment processor is a remarkably accurate recreation of the original code. An attacker will leverage this to conduct further attacks.
So the top one is what your programmer sees. Inside a secure, protected zone with CCTV, all protected. That's what your developers could see. Great. The bottom one was reverse engineered just with common tools from the binary that you distribute to all your customers. No access to your data center, okay? No physical leak. Nobody actually give them any hints. All you got to do is just use these standard tools to do it, and you can see it. And it's almost a one-to-one mapping. Of course, you will lose some context, you lose some. But the point is that you can lift this code. I now know that how I can actually make that payment, what the entry point is. Then I can lift that code, or I can inject code into it, or I can dynamically runtime inject code like swizzling and stuff like that. But all that is made possible by that knowledge. Coming back to why I'm here, so this is, I represent Arxan. So Arxan, we're really focused on building the best possible grade of application protection software and solutions out there. And we are the leader in the space, there's no doubt about it. And at the same time, if you looked at what we have been doing is we have been doing a lot of research on extending that space because, as I say all the time, the bad guys and the good guys, guess what? Use the same tools. There's a constant race. And that's one of the key reasons why we're constantly focused on researching on different ways that we could do it. And I'll talk a little bit about that. I'll make sure I have time for that. But at the same time, it's critical to understand that I can almost guarantee you that you have multiple applications on your phone right now that is actually using our technology. But obviously, because we're a security company, we don't disclose the customer names and so on, so we don't have a slide that basically splashes all the logo, but you'd be super impressed with the customer we're working with. And financial is a major, major customer base for us for obvious reasons. These are just different high-level types of protection. What do we do? So what Arxan does is we provide both control flow obfuscation, just a buzzword, and I'll explain what that is, and also white box crypto. What that means is we take the binary, just from the binary, because the hacker looks at a binary, they don't look at your code. His point is to actually obfuscate the code in many ways. But we actually take the binary, and we not only obfuscate it in the sense that even if you see it, you can't really understand it, but on top of it, we inject what we call guards into it. And these guards are active component within the code. that basically would runtime encrypt, decrypt, move things around, dynamically change things, in some cases even destroy things intentionally to make it look like it's corruption so that if you inject code into it, it will bomb. We have mitigation for debuggers so that if you run it on a debugger or a container, it will bomb, but it wouldn't bomb so obvious because just like any experiment, what you want to do is prevent any kind of predictable output, right? You poke on this side, you don't want to react immediately. So we have different ways that we actually would react in a way that would make it more and more and more and more difficult for the hacker. Again, that's the whole point. You want to extend that timeline as long as possible. Is it ever going to be forever? No. The point is to extend it so long that it's not worth their effort, or they would move on to the next guy, right? But the technology allows the programmer, and in this case, actually most of the time, it's not even a programmer, it's actually the built release engineer, whoever that released the binary, because they don't need access to the source code, to be able to configure and protect different parts of it. And these protections could be built on top of one another. So not only do they actually have to hack and tackle one part of the code, they actually have to simultaneously attack 2 or 3 because they're networked. So you can actually say, I can have one protection, one guard protecting one piece of code, then I have another guard protecting that guard, plus another piece of code, and then on top of it, and so on. And you can build, we have customers that built very sophisticated graph on top of it that makes it very difficult. But the beauty of this is, once you change this graph, guess what happens to the hacker? Next time when you release the code, when you do an update, all you got to do, you're not changing the code binary itself, but use our tool to change the configuration for these guards. It's a completely different way for the hacker to actually have to attack it again. The old way to attack it doesn't work because you mapped the configuration. So you can constantly change it around. You can constantly change it around. You don't have to wait for a new release of a product, just changing it around. And I'm not too sure we have enough time to go through each one of these. But this is high level, what do we do, right? So defend, which is, and we defend both at rest, which is when the application is just sitting on a file. It's a hard disk, right? It's not even running. Or runtime, when you start to run it. And so we defend in the sense that before they can do anything with it, we try to obfuscate it. We try to make sure that it's difficult to understand. It's not just about obfuscation. There's actually a lot more than that. But we make it very, very difficult for the user to understand, like moving symbols around, okay, that's easy to do. Changing symbols, renaming symbols within the binaries, that's easy to do. But we go much further than that, where we would actually damage sections of a code and make it look like it's damaged. Or we would actually encrypt sections of the code, but then we would recover them right before you use them and things like that. And that's defending it. We would also detect. This is runtime application, threat intelligence, which is you need to understand. You can't fight them if you can't see it, right? You have to understand what people are trying to attack. If you see that you have a feature that's constantly being attacked, you might want to think about either slowing down a feature so it deter the repeatable rate, or taking out the feature. But so we have functionality that would actually give you that insight. Whether is detecting the container, is it being run by a container, then you can decide. Let's say it's running a jailbroken device. Do you want to allow them or you don't want to allow them? Or you want to just turn off some feature? Or you want it to crash randomly, right? So it actually fools them. So any one of those options, it's valid. Or if you see somebody actually start swizzle, like plug in, like ASP, you plug into code. If somebody actually inject a code between your payment call to your authorization or whatever it is, would you allow it? Would you want to monitor it? Would you want to wait, or you want to just stop it, right? And then react. We also have built-in reaction that you can actually take reaction to whatever happens. So you can basically say, like I said, just shut it down, or self-repair. Let's say if somebody tried to hook into it, just remove that. Erase it, recover back. And constantly do that. Now, doing that, it's not so much just to recover it, but it's also to deter the hacker as well, because it makes it more difficult for them. Or call home. Tell somebody in the back end. Tell somebody in the server. This is white box crypto. This goes hand in hand with what I just talked about. This is the other piece of the puzzle. White box crypto, in short, is mathematically encryption for both operation and a key set. So remember I mentioned that if you take the key out, you're still going to see it, right? So what we have done is we have implemented all the standard encryption algorithm that's out there, as commonly used by industries. And what we've done is we've done white box crypto around it that basically encrypt both the operations and your keys. So the keys, operations, and some of the data set embedded within that secure section. Now, if your applications start to get in that zone, if you protect that part with obfuscation as well, now your entire application becomes one single unit obfuscated. You can try to read the memory all you want to. You won't see anything. And these are some of the key points in why us. We mentioned about that. I mean, we came from protecting military hardware and software, and yeah. Well, so I think I talked about quite a bit about, you know, the threat, and I hope I've actually shared with you some of the solution that's out there. And so please remember, if for nothing else, the threat is real, and there is a solution. So as long as you pay attention to it, there is a way to actually mitigate the threat. Thank you very much.